we're going to look at the process of hemostasis, or blood clotting. And this is obviously very important because if we have a leak in a blood vessel, if we cut a blood vessel, then blood will leak out because it's under pressure, and it could leak out pretty quickly if it was a cut in an artery. And it's really important that that leak be plugged so a person doesn't lose too much of their blood volume and lose their mean arterial pressure. And the trick is to plug up the blood vessel while this blood is still flowing, because you can't stop the blood flow, fix the leak, and then turn the blood flow back on again like you can if you were fixing a water pipe. And you also don't want the clotting to be so extreme that you plug this whole blood vessel. So in this picture we have a blood vessel. This red line is indicating the endothelial cells lining the blood vessel, and inside the blood vessel we have some red blood cells, and these sort of yellowish round things are platelets. On the outside of the cell we have some collagen fibers. So let's start with severing a blood vessel. So we get something that stabs the blood vessel and cuts a hole in it. And so we end up breaking the membrane here and exposing the blood to the collagen. And what's really important here is that collagen is a platelet magnet. And what that means is the platelets are very, very attracted to collagen, and they're going to start moving towards this collagen, and they actually become activated and sticky. And I made them a slightly different shade of yellow to indicate that these are active platelets. And as they're clumping or agglutinating together, they start secreting a chemical, a paracrine signal called thromboxanes. And TXA2 is the abbreviation for that. And I'm going to draw some little dots of thromboxane chemical in here. And what that does is it attracts even more platelets. So we will have more and more platelets being attracted to this area by the thromboxane. But notice that the thromboxane is just in the area of this developing platelet plug, and it's not in areas where there's no damage. So these platelets do not become active and sticky, but these ones do because of the thromboxanes and the fact that the collagen has been exposed in this area. So as these platelets are clumping together, they form what's called a platelet plug, which is sort of a temporary form of hemostasis, but it's not very stable. The exposure of collagen to the blood also sets in motion a series of chemical reactions that are called the coagulation cascade. So there's several different steps involving lots of different proteins. And at the end of the coagulation cascade, one of the enzymes that becomes activated is thrombin. And why is thrombin important? Thrombin converts a plasma protein, and this plasma protein, fibrinogen, is always circulating in your blood. But it doesn't do anything until the coagulation cascade is activated and thrombin is produced, and thrombin converts fibrinogen into fibrin. So fibrin, which will start being formed in the blood, so let me draw some fibrin being made in the blood here. It's like rebar in cement, and what it does is at the area of this platelet plug, it reinforces it. And what we get is a stable fibrin clot. And this will stay in place while the tissue underneath is being repaired. And in fact, the repair and dissolution of the clot also starts happening at the same time. And in fact, we have another protein that starts to become activated. Plasminogen is another normal plasma protein that is always circulating around, and it doesn't do anything until the coagulation cascade is activated, and it's converted to plasmin, and it's converted by our friend thrombin. So thrombin has two roles. It converts fibrinogen to fibrin and plasminogen to plasmin. And there's also another class of proteins called TPase, or tissue plasminogen activators, that also convert plasminogen to plasmin. And what plasmin does is it dissolves fibrin. So plasmin dissolves fibrin. And this is important because you don't want clots to stay here. Once the tissue is repaired underneath, you want to dissolve the clot away and have your nice unblocked blood vessel. So these clots dissolve slowly at the same, they're basically building up, but they're being slowly dissolved at the same time. So they grow faster than they're dissolved. And so that's the process of hemostasis. We have a platelet plug that is activated when platelets are exposed to collagen. They secrete a paracrine signal, thromboxanes, that attracts more platelets to form a platelet plug. That platelet plug becomes reinforced and stabilized by fibrin, and fibrin is produced from fibrinogen when thrombin converts it to fibrin, and thrombin is produced at the end of the coagulation cascade. And thrombin also converts plasminogen to plasmin, and plasmin is important for dissolving those fibrin clots. So you can imagine that you might have some use for drugs that could dissolve clots, and in fact, synthetic tissue plasminogen activators are important because they can be given to victims of a heart attack or an ischemic stroke to dissolve the clot before it causes too much more damage downstream. So these are referred to as clot buster drugs. And you've also heard of people taking aspirin when they are at risk of developing blood clots. And that's because aspirin is in a class of drugs called a COX inhibitor. And this is short for the enzyme cyclooxygenase, and cyclooxygenase is in the pathway that results in the production of thromboxanes. So I'm going to have COX going to TXA2. And if you inhibit this enzyme, then you inhibit thromboxanes, and that inhibits platelet plugs from forming. So aspirin can actually prevent these plugs from forming in the first place. It can't dissolve a clot if it's already formed, but it can reduce platelet clumping. Reduce platelet clumping. And so people that take aspirin on a regular basis, their blood has a slightly reduced ability to form these platelet plugs, and drugs like Plavix also do the same thing. And so in people that have inflammatory artery disease, this reduces the chance of them forming a clot, which could then break loose and get stuck in a coronary artery and cause a heart attack.